Hey guys, welcome back to another video on the Mathematical Genius YouTube channel. This video is the second video in 7th grade math under the unit of number theory. In today's video, I will be talking about how to find the prime factorization of a number. Before we begin, I am going to really quickly talk about which videos are coming up on this channel. So in the next video, I will be talking about multiplicative inverses. Then in the video after that, I'll be talking about how to find the GCF and LCM of two numbers. Then, how to sort factors of numerical expressions. Next will be scientific notation. After that, classifying numbers, and finally, factorials. So, let's get right into it. Before we start with the math and the actual problems, I'm going to tell you guys a little bit about the prime factorization of a number and how to find them. To understand how to find the prime factorization of a number, we need to first look at the two words, prime and factorization. I know this is a math video, but I'm going to give you guys a quick vocabulary lesson. When we look at the word prime, we think of the numbers whose factors are only 1 and itself. When we think of the word factorization, we think of finding the factors of a specific number. When we put it all together, prime factorization would mean factoring a number until we are only left with the prime numbers. To solve these kinds of problems, we first need to look at an example. There is no real step-by-step method to solving these kinds of problems, so I will just show you all an example, and I hope that you are able to understand. So here is the example problem. What is the prime factorization of 120? The first step we can take is to think of two numbers that multiply to 120. The first two numbers that I come up with are 8 and 15. Since neither 8 nor 15 are prime, we can still factor them. Let's first factor 8. We know that 8 is equal to 2 times 4, and we know that 2 is prime. However, 4 is not prime, so we can still factorize it. We know that 4 is equal to 2 times 2, which means that 8 is equal to 2 times 2 times 2, or as it's actually supposed to be represented, 2 to the third power. Now that we have completed the prime factorization of 8, let's look at 15. We know that 15 is equal to 5 times 3, and since both 5 and 3 are prime, we have completed the prime factorization for 15. Now let's put it all together. Since we need to multiply 8 and 15 together to get 120, we need to also multiply the prime factorization of 8 and 15 together. So that would result in 2 to the third power times 3 times 5. If you don't believe me, go ahead and multiply those numbers out. However, since we can see that 2, 3, and 5 are prime, we can see that this is fully prime factorized. I hope that you guys understand how to do these kinds of problems, but if you don't worry, because we will be doing some more example problems. Let's do 5 example problems together, and then I will give you guys 10 problems to work on your own. So here is the first example problem. Find the prime factorization of 96. Let's first find two numbers which multiply to 96. The first two that I come up with are 8 and 12. From the last example problem, we know that 8 is equal to 2 to the third power. Now, when we find the prime factorization of 12, the two numbers that I come up with are 3 and 4. We know that 3 is already prime, and we know from the last example problem that 4 is 2 to the second power. When we put everything together, we can see that the final prime factorization is 2 to the third power times 3 times 2 to the second power. Now you might not know this, but 2 to the third power times 2 to the second power is 2 to the fifth power. If you don't know it yet, it's okay because that's a topic for another video. So the final prime factorization is 2 to the fifth times 3. Now let's move on to the second example problem. Find the prime factorization of 66. The first two numbers that come to my head are 6 and 11. We know that 11 is prime, so we don't need to worry about that. Let's now prime factorize 6. We know that 6 is equal to 2 times 3, and since both 2 and 3 are prime, we have finished the prime factorization of 6. Now let's put everything together. The final prime factorization of 66 is 2 times 3 times 11. Now let's move on to our third example problem. Find the prime factorization of 89. If we look more carefully and use our divisibility rules, we will see that 89 is prime, which means that the only factors of 89 are 1 and 89. So the final prime factorization for 89 is 1 times 89. Now let's do the fourth example problem. Find the prime factorization of 75. When I look at 75, the first two numbers that I come up with are 25 and 3. We already know that 3 is prime, so we can move on to 25. We know that 25 is equal to 5 times 5, and since 5 is prime, we have finished the prime factorization of 25. Now let's put everything back together. The final prime factorization of 75 is 5 squared times 3. Here is the final example problem. What is the prime factorization of 94? The first two numbers that come to my head are 47 and 2. We automatically know that 2 is prime, but when we look at 47 and use all of the divisibility rules, we can see that 47 is prime as well. So the final prime factorization of 94 is 47 times 2. Now that I have done 5 example problems with you guys, here are 10 problems for you to work on. Please pause the video and work on them on your own, and in a second I will show you guys the answers. So here are the answers. The answer to the first problem is 17 times 5. The answer to the second problem is 2 times 5. The answer to the third problem is 29 times 1. The answer to the fourth problem is 73 times 1. The answer to the fifth problem is 13 times 3. The answer to the sixth problem is 11 times 3 squared. The answer to the seventh problem is 31 times 2. The answer to the eighth problem is 53 times 1. The answer to the ninth problem is 2 squared times 3. And the answer to the final problem is 2 times 3 times 13. Thank you guys so much for watching this video. If you did enjoy, make sure you like and subscribe. In the next video, I will be talking about multiplicative inverses. That's it for this video, and I will see you guys next time.
Just see those sleigh bells jingle and ring.